Hello everyone. I just wanted to start this week with a review of what we did last week, where you looked at data of locations of thunderstorms. You looked for patterns to figure out where thunderstorms in the United States are most frequent and then where they're not very common. And then we learned a little bit about the formation of clouds. And then we went back and used that knowledge to apply what we learned and then make predictions about where thunderstorms might be worldwide. So I just want to go over that briefly, just in case you didn't have a chance to make it to any of the discussions. So as we look here at the data, you can see that Florida pops out here as the state with having the most thunderstorm days per year. And then as you travel up the East Coast here, you can see that number goes down. All right, so as you move up the East Coast, there's less frequent thunderstorms, or even as you move north here, you can see that they become less frequent, with Grand Rapids having between 30 and 40 thunderstorm days per year. Another place you might have noticed here is that this kind of central western part of the United States has a lot of thunderstorms. And what might have also popped out to you is that the West Coast over here doesn't have that many. So if you're looking here, like places in California get about 5 thunderstorms per year. And you can see here in Alaska, there's not very many, and in Hawaii. And I just want to scroll down here though to show you the real locations. Alaska is actually all the way up here. We do have Canada to the north of us. We do have Mexico here to the south. And then Hawaii is actually all the way over here. I just kind of show you, give a sense of our position. All right, so when we look at thunderstorms and cloud formation, we needed a couple things. We needed warm water to get that evaporation, get that moisture in the air. So we need moisture, and that needs to come from a warm water source. And then we also need some kind of uplift, something that is going to move that air up. So severe weather, thunderstorms, tornadoes, hurricanes, they all come from rising air moving upwards. So those are the conditions we need. So I provided you with a couple extra pieces of data here. Here is your relief map. All right, this is showing the mountainous areas and the flat areas like central United States. Florida is flat, and then we have mountains in the Appalachians and the Rockies. And then also ocean temperatures. So you can see here, Gulf of Mexico, very warm. East Coast, we have this ocean current called the Gulf Stream, and it actually brings warm water up the East Coast. Right, and then if we look to the West Coast, we can see we actually have cool water that moves along. That's because we have a cold ocean current coming down from Alaska. So this water along the coast of California is actually cold. I've been in California waters, Los Angeles, in the middle of summer, and it was as cold as Lake Michigan. So that water is pretty chilly. All right, so then looking to interpret our data, if we have cold water along the West Coast, that's going to be one of our reasons for not having very many thunderstorms. There's really not a lot of moisture in the air there. There's really nothing forcing this air up along the coast. All right, but here in Florida, Florida is surrounded by warm, moist air, and you can see here there's a lot of thunderstorms. The middle of the country here, where you see this, here's elevation. It hits the Rocky Mountains, and the wind typically comes from the west. It blows into here. It's forced up by the mountains, which is going to give us a bit more thunderstorms in this area right here. The middle of the United States, right here, I mean 50, that's a lot of thunderstorm days per year. 60, this area right in here has a lot, and that's because it's flat in the middle, which means that cold air from Canada can come in and meet that dry air from the Gulf. So I have here the cold air from Canada. Here, oh, that should have been blue. Oh well. And the warm, moist air coming in here from the Gulf of Mexico, and those two crash into each other. That's going to form uplift, and that's going to give us some serious storms. Florida here has a couple things going on. So if you've been to the beach, you've probably realized during the day when you walk on the sand gets really, really hot, yet you go to the water, it's really cold. So that's going to create temperature differences. That warm air is going to rise, and this cold air is going to rush in to replace it, creating something called a sea breeze. And it's going to come in from all directions. And Florida is extremely flat. And when these hit each other, it actually even comes in from this direction here. They meet in the middle. This is convergent uplift, and they crash into each other and they go straight up into the air. And this gives Florida a lot of afternoon thunderstorms. And so this is one of the main reasons why Florida, with its moisture, its flat land, we have the sea breezes come in, they hit each other, causes convergent uplift, and they get lots of thunderstorms. Now we want to look at applying and predicting what we have learned, because that's the whole purpose here, is that we're trying to predict where these disaster events are going to happen so we can better prepare these areas for that. So what I asked here is that you just circle 3 areas in the world outside of the US, because we already looked at that you think would have a high frequency of thunderstorms, and then kind of explain why. So as I talk to students, all right, some of the common areas that they circled that might have a high frequency of thunderstorms, a lot of them, and I said along the equator, because that's where the sun's energy is the strongest. So some places along the equator that people circled were here in Central Africa, here in South America, and then also we said we need not just warm water, all right, and things heating unevenly, but mountains can sometimes force air up. So we looked for some mountainous areas. So you can say here in Asia, I had people circle these islands here in the Pacific because they're surrounded by warm water, plus they have mountains. So those were good predictions there about locations that would possibly have a high frequency of thunderstorms. Then moving to areas with a low frequency, a lot of people put that colder areas. So Greenland, or down here, oops, in Antarctica, that's kind of out there. It's cold. All right, there's cold water. You're not going to get much water vapor, so not a lot. And then they also said areas that aren't going to get are places that are typically landlocked. So right here in the middle of a continent, not going to get a lot of moisture. So maybe like the middle of Australia, and maybe like the middle of North America here were some common predictions. All right, so now we're just going to look and see how these predictions worked out, if I can. All right, so scrolling down, this is the location of thunderstorms worldwide, and the predictions that a lot of you put in were pretty dead on. So you can see here we have lots. I mean, the central part of Africa has the most worldwide per year thunderstorms per year. We do have some down here, a lot. And here's the rainforest here. We have some flat areas. You can have some cold air coming in from the south, warm, moist air coming in here. So that's going to cause some thunderstorms. The mountainous areas here. These are the Himalayas. These are the highest mountain ranges in the world. This is where Mount Everest is. And yeah, absolutely these islands over here with mountains and surrounded by warm water. And these predictions that you had about locations where there's not going to be a lot, the middle of the land area is very correct. All right, so up here in Russia or the middle of Australia, not a lot of moisture. And I mean, Antarctica, hardly any. Right up here in the North Arctic, not very many. The only exception here is we said that the landlocked areas might not have a lot of thunderstorms. However, the middle of the United States does. So there's something unique about the middle of the United States compared to the middles of the other countries that are going to allow for thunderstorm formation. What I do think is interesting is also that there's not a lot of thunderstorms over the oceans, which when I studied this, I thought there'd be a lot more. There's not, but if we think about it, what heats up faster? The land heats up faster. So we're going to have more rising air over the land versus the ocean, which is really hard to change temperature. All right, so that is your review I wanted to give you an authentic experience. What we do as scientists studying disaster events, and one thing we look at is location, and we have to look at data, we have to look for patterns, we have to look for explanations, and we need to apply those to what we've learned and then try to predict where those things are going to happen.